Good morning, everyone.
Good morning, ma'am.
So yesterday we started a new chapter, that is acid, bases and salts. What we learned yesterday was what are acids, what are bases and some of their physical and chemical properties. Now we will start a new concept. Before we start that, I will ask you a few questions. If you know the answer, please raise your hand. Can you do that?
Yes, ma'am.
Alright. What happens when you dissolve any acid into water? Yes, please.
Hydrogen ions are released.
Very good. Hydrogen ions will be released. Sit down. What happens when you dissolve a base into the water? Yes? Also known as?
Hydroxide.
Very good. Very good. Sit down. With the touch, if you touch any acid and base, can you get to know which substance is acid and which one is basic?
Yes.
Based on the touch only?
Yes. Yes. Yes.
Yes? Okay. Who will give answer for this one? Yes, please.
Ma'am, if we touch a base, we feel something soaking our hand.
Very good. Slippery touch will be there. That is also known as soapy touch. Today we will try to learn that there are certain substances which you can't touch, which you can't taste. Based on that, you cannot find whether that substance is acidic or if it's basic. Let's say, have you ever heard about acid known as hydrochloric acid? Yes, because we have learnt that. HCl, can you drink that? So with the taste, can you identify that, okay, this is HCl, this is acid, can you find? No. For these kind of substances, we have special thing to test whether a substance is acidic or basic, and that is known as indicators. That is known as indicator. I am writing as because we will be talking about plural. Indicators are those substances which are used to identify whether the given substance is acidic or basic. Fine? So, shall we write the statement? It is used to identify. Identify. What we need to identify? Whether a substance is acidic or basic. So, we will check whether a substance is acidic or basic. That is the main thing. I have certain indicators with me. We will check the same experiment, that whether a given substance is acidic or basic. Indicators are mainly of two types. We will divide them into two categories. That is one of our learning objective as well today. Define indicators and their needs. Indicators are the substances which are used to check whether the given substance is acidic or basic. So that is the need, because there are certain things which we can't drink, we can't touch. Example, hydrochloric acid. If you touch that, obviously your skin is gonna burn. Do you want to burn your skin? No one wants it. And that is why we use indicators. Sometimes we get transparent solutions. 3 or 4 transparent solutions are there. How will you get to know that which one is acidic, which one is basic, or which one is neutral as well? That is why we need indicators. Next learning objective is identify different types of indicators. Now indicators we divide into two categories. First category is natural indicators. Natural indicators. And second category is synthetic indicators. Second one is synthetic. I think you all are familiar with the names. What do you mean by natural indicator and what is synthetic? Natural and synthetic. Natural is something which we get from nature. As simple as that. In natural indicators, we will learn about turmeric. We will learn about China rose. China rose. Many more are there. Natural indicators. In synthetic, we can learn about, let me change the color. we will learn about, say, methyl orange. Methyl orange. We will learn about phenolphthalein. Let's see how it works. Oh, one of the most natural indicator we forgot to write. That is litmus. Litmus. Let's see how it works. When we talk about natural indicators, means these are the indicators which we get from the nature. Example, turmeric, China rose, litmus. What is so special about litmus? You all know turmeric. Obviously, we get it from nature. You all know about China rose, also known as China rose. Other name of China rose is
Hibiscus.
hibiscus, isn't it? So, again, we get this from nature. Now we will talk about litmus. How litmus can be a natural indicator. How litmus can be a natural indicator. Any one of you who can tell me something about lichens? Have you ever heard about it? Lichens. Yes, please.
Lichens are a combination of algae and fungus.
Very good. Sit down. So that is the dye which we use. We will sit down, beta. Sit down. Please move. Give them seat, please. Thank you. Please give them seat. Okay. Now when we talk about litmus here, litmus is a natural indicator because we get it from lichens. So it's a kind of a dye which we use. We get it from lichens. That's why it is a natural indicator. Now I have China rose with me. What I have done is I have boiled China rose in water so that I can get a solution form. I will take this and pour it into the test tube. It's still warm. Okay, let's see. This is the first test tube. Alright. And another test tube. Again, I will pour China rose in it. Okay. Now we will see the changes with acid and base. What happens? Firstly, I am taking acid and we will observe the change. What happened? Color changes into? Very good. Now we will take a base. Let's see what happens. Green in color, isn't it? So, if you will see here, acid, base, transparent liquids. With a look, you cannot identify which one is acid, which one is base. But if you will see the test tubes now, can you identify?
Yes.
Which one is acid, which one is base? This is acid. And this color change with the base. Isn't it interesting?
Yes, ma'am.
So, let's see what we have figured out. When we took China rose with acid and with base, we will write the color changes. I will draw a table here so that we can clearly identify. Fine. This much is enough. Okay. Back to the pen. Which China rose color change with acid was?
Pink.
And with the base? Green. Fine. So this is natural indicator. Let's talk about synthetic as well. Is synthetic or should we take litmus as well? Okay. Before proceeding to the synthetic, let's talk about litmus. Litmus. We will talk about two litmus. One is blue. Another one is red. Let's see both litmus. In one, I am adding acid, one of the test tubes. Acid. In another test tube, I will add a base. A base. Now, since I have written two types of litmus are there, blue and red, I will start with lead litmus solution. Acid, red litmus, and let's see what happens. Something happened. Red color remained.
Red.
If I take base and red litmus, one second. Oh, sorry. My bad. One second. Sorry. So now check. With the base, what happened?
Blue.
It turned into blue. With acid, was there any change? With base, red litmus turned blue. Again with acid, red litmus remained red and base turned blue. Let's write here. Acid with red litmus, no change because it remained red. What happened to base? With base,
It turned blue.
it turned blue. Even here, same change you will observe with the blue litmus as well. Now we will check with one of the synthetic indicators. Before we go there, let's see something interesting. Okay, till that time, it should not take this much time. Just give me a second, let me refresh the page. Okay, now we will do this experimentally. Firstly, we will see on the screen and then we will perform. Any one of you? Can you please come in? Let's see what happens. Okay, drop this here.
Excellent.
Done.
Try again.
Done. Now what happened? Phenolphthalein changed its color when it reacted with base. What is the color change? Pink. What is the color change? Pink. Means whenever you add phenolphthalein into a base, color change is going to be pink. Now because this transparent changed into pink color, it showed that the given solution was a base. Yes.
Excellent.
With acid, did it show any change?
No change.
No change means that this given transparent solution is an acid. So we had two things, acid and base. Earlier we had no idea. But when we used phenolphthalein, it showed the change with the base, but with acid no change. So which showed that the solution which turned pink is a base and the solution which showed no change is an acid. Clear? Now we will use methyl orange. Yes.
Excellent.
Can you see the change here? That is, so it showed that methyl orange turns actually a kind of reddish whenever we have an acid. Now here we only know the color. We don't know which solution is this. Let's see.
Excellent.
Yellow color means base. Let's prove this. Thank you so much. Please sit down. Okay, let's try this now. We will try with phenolphthalein and methyl orange both. In one test tube, I am taking acid, transparent solution, in another test tube, I am taking a base. What we will use now? Methyl orange. Let's check methyl orange. This is methyl orange. Let's see the color change. This is the same color? Yes. All of you can see that? Yes. That means methyl orange with acid gives this particular color. Can you see that? Yes. Now we will check with base. Base, methyl orange. What should be the expectation? Let's see if we actually get the yellow color. Oh, sorry. 1 second. With a base, just give me a second, better. Okay. Methyl orange. Sorry. Let's see. What is our expectation? Yellow means yellow. Okay. Now, see? Isn't it the same? Yes, ma'am. Again, I will show it to you for your confirmation. With acid, indicator is methyl orange. With base, isn't it same? Yes, ma'am. Let's check with phenolphthalein now. We will check with phenolphthalein. Here I have taken acid again. Acid. And now I will take base. And indicator is going to be phenolphthalein. Here I have taken. Here I have base. Firstly, let's check with acid. Is there any change? Is there any change? Same? No difference? Now we will check the same with a base. What happened? Isn't it? Now let me show you something interesting. This is done again, bitter with acid. Is there any change? With base? So phenolphthalein as an indicator. Let me show you something really interesting. This is base with phenolphthalein indicator. Because the color change is pink, we got to know that given solution is base. Let me add some acid and let's see what happens. What happened? The color disappeared, isn't it? If I'll add some more acid, see, color is disappearing, isn't it? See, color totally disappeared. See? What happened? Color disappeared. The pink color disappeared. Now what happened? We had a base. We added phenolphthalein. The color change was pink. That means we had a base. Indicator is fine. We had a base. And then I added an acid in that. And pink color disappeared. This reaction is known as neutralization. When an acid reacts with a base, it gives us a neutralized product known as salt and water. So neutralization. I am giving the introduction now only. This is neutralization reaction. Isn't it interesting?
Yes, ma'am.
Okay, now let's see a video. Okay, there are 2 videos which I have uploaded here. Let's see this.
Zara and Zen were all excited to perform a series of tests on a few solutions to find out whether they're acidic or basic. Their teacher handed a few yellow-colored paper strips, and before she could return to guide them, Zen had already dropped a few drops of some solution on it. And to his surprise, the paper turned bright red. Both Zara and Zen were confused with this magic. How did the paper turn red? The teacher returned and explained that the two had performed one of the detector tests. They were supposed to detect whether the solutions given are acidic or basic. And since the yellow paper changed color and turned red, it indicated that one solution was tested. But how does this paper tell us the nature of this solution? Do you remember understanding the concept of indicators in the previous video? These are nothing but substances that help us detect whether the given solution.
That's what we have learned about indicators. These are the substances that helps us to identify or to detect whether the given solution is acidic or basic. Based on the color changes which we are getting, we will decide that whether the substance is acidic or basic.
Is acidic or basic without having to taste it. So is this yellow paper an indicator? Yes, it is. And what is this made up of? It's simply a blotting paper with turmeric applied to it. Turmeric? Yes, it is. The same turmeric that's used in the kitchen. Turmeric is an excellent indicator.
Is turmeric natural indicator or synthetic? Natural. Always remember that turmeric will show no change with the acid. But if you have any turmeric stain on a piece of a cloth and you are trying to clean it by using a soap or detergent, obviously, have you ever seen the color change in the stain? Yes, isn't it? What is the color change then?
Red.
Yes, a kind of dark red color will appear. Turmeric itself is of yellow color. So turmeric is a natural indicator.
To detect the acidic or basic nature of the solutions. In this case, the paper turned red when the solution was poured onto it. So, what did the indicator tell us? It clearly indicated that the solution was basic. Yes, alkaline substances or solutions turn turmeric into a red color.
That's what we have learned, that whenever you add a base on a turmeric stain, the color change will be red.
The basic nature, brighter the red color will be. And what about acids? Acids have no color change when tested with turmeric. The color of turmeric, which is yellow, remains unchanged.
It will remain unchanged. Clear? How can we use turmeric as indicator? Since we get turmeric from the nature, we call it as natural indicator.
The previous video got us familiar to the concept of indicators. Indicators are the substances that are used to detect the acidic or basic nature of solutions. We have seen how turmeric acts efficiently as a natural indicator. Now let's talk about another natural indicator, and that is China rose.
We have done this.
China rose is a plant. So how can that be used as an indicator? The fact is, the flowers of China rose possess a good ability of detecting acids and bases. So how do we use China rose flower as an indicator? It's very simple. All we have to do is add hot water to the petals of China rose in a beaker and let it rest for some time. This solution can be used as an indicator. When drops of this are added to an acidic solution, then the color of the solution changes to magenta red or a slightly different shade of red for that matter. However, when added to an alkaline solution, the color of...
What is the color change with the base?
Green.
Green. Very good. It's a green. I think we showed that. Okay. Okay. I can't find the test tube. I think this was the one. A kind of green color will appear. It has changed now, but if you will keep it for a longer time, a bit change may observe. Okay, but with the acid, what was the color change? Pink. With the base, green.
The alkali changes to green or yellowish green to be precise. The solutions change color in very less time. And that is how we use China rose as an indicator. However, sometimes it's not very convenient to add the indicator to the solution. In such cases, some different type of system is required, something more efficient. So in such cases, litmus paper comes to our rescue. What are litmus papers? Well, before that, tell me, have we come across the terms lichens? Yes, we have studied in biology that the symbiotic relation of algae and fungi gives us a unit called lichens. The major function of lichens in an ecosystem is that they act as a pollution indicator. Their growth is hindered when there is excessive pollution. As a result, chemical changes in the body of lichens can give us indications of the nature of substances that come in contact with them. So a substance extracted from a lichen's body called litmus is used as a natural indicator for chemical purposes, especially in detecting the acidic and basic nature of solutions. The litmus obtained from a lichen's body is a mixture of some dyes that are usually absorbed on a filter paper. This paper made with litmus on it is used as an indicator for detecting acids and bases. Two colors of litmus papers are usually available: red litmus paper and blue litmus paper. The red litmus paper, when comes in contact with an acid, displays no color change but turns blue in presence of a base. In contrast to this, the blue litmus paper turns red on contacting an acid while it remains unchanged in a base.
Let's go back to our whiteboard. We will continue the same one. That's what we were doing here. Let's see. Red litmus with acid will show no change, whereas with base it will turn blue. Here. Now when we take blue litmus with acid, will there be any change?
Yes.
Which color?
Red.
Very good. And here? No change. Very good. Here it's going to be no change. Next is we can talk about methyl orange. Methyl orange with an acid, what was the color change? Magenta, a kind of dark pink color. So we can write as pink or magenta color appeared. And with the base, it remained yellow. That's what we have learned. And at the last, when we talk about phenolphthalein, what was the change? Phenolphthalein with an acid, is there any change? No change. And here it turned pink. Very good. Here it turned pink. There is a small worksheet which we can solve now. A really small worksheet. Okay, here is it. Let's try to solve this. First question is, a solution changes the color of turmeric indicator from yellow to red. What will be the nature? Is it neutral? Either neutral or acidic, basic or acidic? We have turmeric as an indicator. The color changes from yellow to red. What will be the nature then? Yes, beta? Basic. Very good. Second is, we have dry HCl gas. Dry, it's not a solution, it's a dry gas. So there is no change. Why is there no change with the dry HCl, whereas with liquid we have seen the changes? Hydrogen gas is evolved only in the presence of water. Water provides acidic character. The hydrogen ion is produced in aqueous condition. Acids show acidic property due to water. Yes, Vita?
Because the hydrogen ion is produced in aqueous conditions.
Very good. Sit down. Which of the following is natural indicator? Is it methyl orange, oxalic acid, phenolphthalein or turmeric? Yes, Vita? Turmeric. Very good. Turmeric is natural indicator. Okay. Litmus, a natural dye is extracted from? Litmus is extracted from? Yes, beta. Lichens, very good. Okay, there are certain soluble. Okay, this we still have to do, but it's fine. All bases are not soluble in water. There are certain which can, and water-soluble bases are known as alkalis. They are known as alkalis. One second, there is one more question left. Yes. Both acid and bases change color with all the indicators. If an indicator gives color change with acid, it does not show a color change with the base. If an indicator changes colors with the base, it does not show the color change with acid. Change of color in an acid and a base depends upon the type of indicator. Which is the correct statement? Yes, beta. D. Very good. Because it depends upon the indicator which we have taken. Is this clear, beta? Any doubt? No doubt? Are you sure? Okay, fine. Now this is the last video which we will see.
Indicators. An indicator is a chemical substance used in small quantities in titrations and volumetric analysis to determine the equivalence point or end point based on a significant change in color. Indicators will be very sensitive to certain changes in the conditions with regard to chemicals, their pH, or their oxidation states. Depending on their use, indicators may be one of several types. When indicators change their color with respect to the change in pH values, they are known as either pH indicators or acid-base indicators. A pH indicator is a weak acid or weak base, and color changes are displayed over a range of hydrogen ion concentrations. This range is the color change interval and is expressed as a pH range. These indicators are used in acid-base titrations to determine the equivalence point or end point. Let's look at a few examples of these indicators. Thymol blue has a pH range for color change of 1.2 to 2.8.
So that is a substance which we have not learned yet. That's why we are seeing a video here. Let's see.
In acid solutions, it will display the color red, and in basic solutions, the color yellow. Methyl orange has a slightly higher pH range of 3.1 to 4.1.
Methyl orange we are already done. When we talk about methyl orange with acid, what will be the color change? A kind of dark pink or kind of magenta color will appear. Whereas if I talk about base, what is the color change? Nothing, it appears to be orange. That's what we will see.
In acid solutions, it turns red, and in basic solutions, it turns orange-yellow. Phenolphthalein, with its pH range of 8.3 to 10.0, will be colorless in acid solutions, but in basic solutions, it will turn a reddish-violet color.
We call it as a pink color, which we have seen. Any doubt? Okay, let's quickly summarize what we have learned with a small quiz. Okay, let's see. A pH paper turns bright red on dipping into a solution X. What would be the nature of the solution? Riti, can you please come and check? Click on the correct option and submit. Dark red. Submit. Very good. Sit down. Okay, let's check one more question here. All acids and bases cannot be tasted. So, how their nature can be determined? Click on the correct option and submit. One more question. Acidic substances taste. This we have done earlier. Yes, please. Very good. One more question. Which among turmeric solution, red rose extract, onion and beet juice is an olfactory? Olfactory means related to? Olfactory means related to? Nose. Very good. Related to smell. So what do you think? Which one is related to smell? Raise your hand. Yes, please. Very good. Sit down. So that's what we wanted to learn today. That is, what are indicators, why do we need indicators, and what are the various types of indicator which we have. So define indicators. Can anyone define the term indicators? Yes.
A solution used to test whether a substance is acidic or base.
Very good. So these are the substances which used to detect whether the given substance is acidic or base. Why do we need it? Why do we need indicators? Yes, please.
Because some strong acids and base we cannot taste to determine it.
Yes.
So using indicators we can detect.
Very good. Only taste, can we touch them? No, yes. We can't touch, we can't taste certain indicators. That's why, we can't taste and touch certain substances. That's why we need indicators to check them. Identify different types. What are the two categories of the indicators? Yes, beta.
Natural and synthetic.
Natural and synthetic. Sit down. Name any two natural indicators. Yes, please.
Turmeric and China rose.
Turmeric and China rose. Name any two synthetic indicators. Yes, please.
Methyl orange and phenolphthalein.
Very good. Methyl orange and phenolphthalein. Any doubt into this topic? Everything is clear?
Yes.
So thank you everyone for your cooperation. See you in the next video.